Okay, welcome everyone to the SGP.32 webinar. So I'm hosting this together with Loic from Keegan. We'll do a quick round of introductions in a minute or so. So we give everyone, let's say 1 or 2 minutes to actually get access to this online webinar. And then we're going to kick off in roughly 1 or 2 minutes. So in the meantime, drop a message in the chat. Let me know who you are and where you're from. So at least we know that we're actually talking to real people here. Loic, where are you calling in from?
Yeah, hi Laurence. I'm calling in from Aix-en-Provence in France, in the south of France, close to Marseille. So,
all right,
great to be here.
Thanks so much for joining. So yeah, I'm based in the Netherlands, in The Hague. It's great that I see the first messages from Brazil, from UK, from Egypt, from Dublin. So lots of people, lots of different areas we're covering today. So thank you so much for joining. In the meantime, let me share my screen. And then we are slowly kicking things off. Oh, wow, lots of countries. US, India, Sweden, Indonesia. Okay, this is really exciting. And yeah, it means a lot. Thanks so much for joining. And this has been a fun experiment, the SGP.32 reality check. At least it was for me. I know that the guys at Keegan, they have so much experience already, so I think the results might not be that surprising for that whole team. But at least I'll guide you through my own story on my experiences with testing out this remote SIM provisioning standard. And before we kick off, big thanks to the partners involved. So Keegan for helping me set up everything, as well as the connectivity partners, Zariot, Soromondo, and Soracom and Alamondo. And I actually have another company that I'm highlighting as well later in this presentation, which is called Koitech, and they have these very nice power analyzation tools. So before we dive in, Loic, would you like to share a few words about who you are and what you do so people know who you are?
Yeah, sure, Laurence. So yeah, I'm Loic Bondalet. I'm the SVP of Marketing and Ecosystem at Keegan. Keegan is a spin-off coming from the ARM ecosystem. And I'm in charge basically of working with our entire ecosystem of cellular module solution partners and to really promote what Keegan does in the eSIM space. So really providing everything you need for eSIM solution, eSIM and iSIM solutions. So great to be here. I'm based in Aix-en-Provence, and I've been working at Keegan and ARM since 2018.
Since 2018. All right, lots of experience. Thanks so much for joining. My name is Lawrence. So I run the IoT Stars community together with my partner, Mark. And we try to bring IoT professionals together, either at in-person events or at online sessions like this one. A bit of housekeeping. If you have any questions, make sure you drop them in the chat, and we'll address as many of them in the Q&A at the end of this webinar. But as there's a demo, there might be a few parts where we actually have to wait for something is happening, so I might already address some questions there. So don't hesitate throwing your questions in the chat, and we'll make sure to address them. We try to keep it short, so we're aiming not to use the full hour, but let's see how it goes and how many questions there are. Again, big thanks to the partners involved. And we start off with a quick word of presentation from Loic, explaining what this Keegan SGP.32 actually is and what components it all entails. And then it's my turn to give you a live demo on how this works in practice. I have a few slides about the time and the energy consumption of updating SIM profiles. And then we end with a conclusion and some Q&A. So without further ado, I'd like to give the floor to Loic to kick off this presentation.
All right, great. So I will share my screen. Okay.
Perfect.
So yeah, I will give you a short presentation about the SGP.32 reality check. And first of all, we'll start with a quick intro of who Kigen is. So Kigen is a company of roughly 130 people. We are based in the UK. We are a spin-off from ARM, and we are really focused on providing eSIM solution, eSIM and iSIM solutions. So we've been doing that since 2020 as Kigen. Between 2018 and 2020, we were part of ARM still. And so since then, we are really focused on serving the IoT and really focused to serve the OEM who build connected device via cellular. We have a presence in 10 countries. We have a data center in Ireland, development center in Belfast, in Noida, in Copenhagen for OS. So very diverse background from many countries, and we have a global presence for sales as well. So first of all, I wanted to start with a quick slide on the changes introduced in this so-called SGP.32. As usual, GSMA loves to have great acronyms for standards, but I'll walk you through a few of the key changes compared to the previous specification of what we call remote SIM provisioning. So this started with M2M, focused on automotive and connected cars to start. And then the consumer specification, most notably well known for example, for the Apple ecosystem, which really brought eSIM technology to the masses, and now SGP.32. And SGP.32 really take the learnings from both past standards, which are eliminate the complexity from O2, from the M2M world, remove SMS. SMS is no longer needed for SGP.32. We remove complex network integration as well. We then adapt the consumer specification, notably for the card, to include several new components, notably the IPA that we'll talk about a little more, and really leverage the infrastructure of existing SMTP+ that are deployed by many operators and MNOs all over the world. Then there is a new component called the EIM, or eSIM IoT Remote Manager. This is the kind of central router of managing a fleet of devices with eSIM in the field. That's quite close to the former SMSR, but in a much simpler and flatter architecture. And the new element, which is quite important, which is this IoT Profile Assistant. It's an evolution of what is known to be the local profile assistant in the consumer world. It's a piece of software that runs either inside the eSIM, the EUICC, it's then called an IPAE, or it runs inside the device, the IoT device, in the MCU or in the cellular module, and it's then called an IPAD for daemon. So we wanted to really outline what is an eSIM solution, and quite often people might think, well, an eSIM is just a piece of plastic or the solderable hardware that goes onto your device. Well, yeah, that's the physical asset, but in effect, you need more to run a full eSIM solution, especially if you want to operate a fleet of devices. So you need a platform, which is typically made of access to the EIM, the eSIM IoT platform manager. And you will also need some tools, which can be preparing your card, the IPA, if you need to embed that software into your devices, etc. So the central piece here is really what is certified by the GSMA, EIM and eSIM. But yeah, we provide a lot of the extra tooling necessary to deploy your full solution, whether you are an OEM or a connectivity provider, or even a different person or an enterprise looking to manage this fleet by yourself. So let's look at these different elements. And here, well, the most well-known element is the eSIM itself. And what's interesting is eSIM sold, originally made embedded SIM, but actually you can have eSIM functionality with a plastic SIM. And that's very useful when you have an existing device and you want to test the eSIM technology without changing the hardware of your devices. You can actually do that. We have several customers who went through that journey to actually test the technology, download profiles, download various MNOs profile with a plastic eSIM in an existing, say, gateway. We have Robustel as a good example of that. So that's for the plastic card, but we have also a variety of solderable form factors that are available. Most important, the product is fully certified and it's compliant to both consumer and IoT specification in the specific case of Keegan. Then we come to, so we are climbing up the stack here, and we come to the tooling, what we would call the middleware that runs either inside the device or inside the eSIM. That's software that enables the whole flow to work. In our case, what we deliver with our target to focus on IoT, a C SDK, right? So C source code that is highly portable and that we use also for own internal use cases. For example, flashing card in a factory, we use the same set of source code compiled for different platforms, PC, Raspberry, whatever you would like. It's really portable. And among these pieces of software that are included in the middleware, you have what we talked earlier about, which is the IPA, right? And I'll do a very quick classification of IPA. When we have our customer testing our offer, so our eSIM embeds an IPA-E, so that you see on the right here, which is typically doing what's needed. For example, if you deal with cellular-only devices, no extra bearer, pretty low power in terms of functionality on the MCU. This is typically working just fine with a piece of software that runs directly into the eSIM and manage the connection to the EIM. Now, if you work with a more complex device, say, for example, an Android or Linux-based device, a gateway that needs to deal with multiple bearers, you might want to have an IPA-D, which would be running on the MCU. That allows you to have a finer grain control over, for example, the provisioning flow. You can use cellular, but you can use also, for example, a Wi-Fi or cable or Bluetooth to download a profile through that channel. We have customers doing that on gateways, for example. And we have an extensive blog on IPA versus E versus D on our website. You have a reference below here. Now, the other big element, that's it for, I would say, a quick overview of the embedded part, but the big element is the platform, right? And access to an EIM functionality. And so what we did at Keegan is to basically certify first our EIM with GSMA. That is, it's running in a data center, which is what we call SASSM accredited in our Dublin data center, right? And we went through all the GSMA qualification. We were first to market on this certification. And on top of that, we built what we call an orchestration layer, which is our Pulse layer, which basically gives you access to all the EIM functionality. You see here an extract of, for example, all the API available. Anything that you see in our UI is also is using the same API internally for a smooth integration with, for example, our connectivity partner offer and connectivity management platforms. So the typical scenario that we see is that first, our customer, the developers, they test the UI, but very quickly they move to the API integration into their own workflow. Because that's typically how it's driven. It's a business trigger that will potentially trigger a profile download or something along those lines. So the same Pulse platform gives access to our entire suite of services, whether it's SGP.32, 22, O2, factory provisioning, or security services. And talking about security services, we made the innovation as well that our EIM platform includes de facto the ability to do software lifecycle management, notably for the eSIM OS. So that is, we ensure that if you use a Keygen eSIM with Keygen EIM, you have access to security patches should we deploy any of them onto the eSIM itself. That is an elegant way to ensure that you can have you can be prepared for CRA and use a platform that you already need anyway for your workflow. This is the data center is our own hardware running in Dublin, and also we have a data center in Noida to be able to deliver that functionality, which is audited, to answer Alberto's question. Now, coming more to the ecosystem bit of it, what's really important is to have a healthy and working ecosystem. And one of the first and most prominent element of a cellular connected IoT solution is the cellular module. I come from this space. I spent 10 years working as an FAE and technical sales director to help a module integration in the past into devices. So it's very important to make sure that our eSIM solution work well with a variety of modules, and we've tested all the key players in the space. More than 50 module referenced publicly already. You have a QR code for the list here, and we continue to grow this list. We have Fibocom who's joining shortly this list, and a few others. And we've tested across all the key players also on the chipset, that is Qualcomm, ASR, Unisoc, MediaTek, Sony Altair, Sequans. We've tested the platform with all these guys already. So that's for the more embedded part. And for the platform part, we've done also multiple EIM testing. We've done already 5 third-party EIM testing with our eSIM. We have also tested third-party middleware or IPA. So, for example, some cellular module vendor use their own IPAD. We've tested against that as well. And we've also integrated a lot with connectivity management platform. For example, with our MVNOs partner, which are supporting this webinar also with their profiles. They've done most of the time some type of integration already with Keygen for EIM or SMDP+, or of course our eSIMs. We also do integration with, for example, CMP platform, which are in autonomous vendor, the people such as Symmetric or IoTM, which provide a single pane of glass to drive both CMP transaction and eSIM transaction. Okay. So a lot of work on the ecosystem. So to wrap up this presentation, just wanted to walk you through there on this slide on a few key events through our journey on SGP.32. We were at the origin of the spec with our head of standards, Said Garou, who did a lot of engagement. He was leading the working group. He's leading eSIM working group to a GSMA. So we have really one of the best experts standardization-wide in the house who help us drive the product design as well. We have our EIM hosted in our SAS center in Dublin. We have our eSIM ESA certified. We do a lot of integration with our Secure with Keygen program and with top players, including the big names to answer Alberto's question. So Thales, for example, we did already some pre-testing. And we're preparing also for the future. We have already deployed with some customer solution for IFPP ahead of the standard, and we make sure that what we deploy is also part of a light framework on IFPP. Yeah, so quick conclusion from my side. I'd say the technology from a certification and availability standpoint is fully mature. and it really decorrelates the hardware choices that an OEM would make and their connectivity choices, right? They can source a variety of digital profile, and that enables really this BYOC concept. Bring your own connectivity. You have an existing contract with an MNO and MVNO, make sure they can deliver their profile in a digital way, and you're good to start and have options. And that allows this connectivity provider to actually differentiate truly on their value add, on their platform, on their coverage, on their radio tech, and for end-to-end journey. IPAE is an essential element of our product with ability to work out of the box with plastic card. This is a scenario that we see more and more. We deliver these software update life cycles. And finally, I would say my recommendation is play with the tech yourself. And that's what Lawrence did. It's really important to test this stuff end-to-end with your module, the eSIM, the targeted connectivity provider, because ultimately, when you have to do a switch on a large fleet, it's still a very committed move, right? You need to make sure you've tested all this, especially the target coverage and the impact on the change of connectivity provider, so that you have a really smooth and good transition there. So that stays really important, but we do a lot of the heavy lifting of this qualification with you ahead of you as much as possible. And with that, I will give the floor back to Lawrence, and we'll try to address some of the questions as we run through the demo.
All right, thanks so much, Loic. So this might be still a little bit abstract, so I'm trying to actually show the part that you tried to explain. And I'll show you quickly what my desk looks like at this moment. So I have different devices because, as you mentioned, it needs to be tested in different scenarios for different deployments. So I have here a kit from SD Wireless. I have something from attendees with the Nordic NRF9160 chip. I have a Murata module with the Type 1 SC. I have a Walter module with the Sequence Monarch module. And I have a whole setup with the NRF9151 that's connected to the Koitek Power Profiler. And if we have time, we can go into that in more detail. So when I first connected with Keegan, I actually got a bunch of SIM cards. So I simply received these plastic SIMs that contain this EUI-CC, which you need for using SGP.32. And on this SIM runs the so-called Keegan OS or SIM OS. And in this SIM card, basically the IPA runs. And it can be, in this case, a plastic SIM, but in essence, it can be an embedded SIM as well that you solder directly onto this board. So to give you a demonstration right away, I'm going to connect the SIM card to this specific module from Walter, and I'm connecting it with power. And in the meantime, I am sharing my screen. And it shows you that's demo time. Okay, so I not only received the SIMs with the IPAs from Keegan, but they also received access to the Keegan Pulse platform that Loic referred to. And this is basically the management portal where you can manage all your SIMs. And from here, so-called operations can be initiated, like enable a new profile or download a new profile, or I don't know, these types of things. So I have here the different SIM cards with different profiles that are associated with a specific EID. Rather than just using this platform, I thought let's try out actually the APIs from Keegan itself and try to implement this into my own web application. So I did so, and this is basically what I built. So I not only integrated the APIs from Keegan, but I also integrated the APIs from the connectivity partners that I'm working with. So Zariot, Soracom, and Anomondo. Okay, so in the meantime, hopefully this device now connected to the internet, and I'll directly show you the first part of this STP process. So quite often, if you receive a SIM card, it comes with a so-called bootstrap profile. And that is an initial profile that allows the SIM card to connect to the internet. Because, I don't know, it needs to receive instructions from the cloud. So there needs to be a way for the SIM to actually connect to a specific server. And it's usually what we call a bootstrap server. And sometimes it comes with additional profiles on the chip itself. So let's directly start off with the demo, because this SIM not only has this bootstrap profile, but it also has the Zariat profile on this SIM already. So I'm opening, I click on this profile and I simply select enable. And how it then works, so the IPA, the piece of software that runs on the SIM card, checks in with the EIM. So I'm using the EIM from Keegan. And that EIM now has a pending operation listed for this device. So if the SIM checks in with the server, it actually validates that, or it receives that operation to enable that different profile. And as you show, it's pending, and every so often it checks in with the EIM, and it can happen at configurable intervals. And by default, I set this to every 1 minute. So it might take a minute before the operation is actually being activated. I'll share you more information about the duration of all of this at the end of the presentation. But at least let's refresh, and maybe we already see that something is happening. And actually, while we're waiting for this process to be completed, I'm directly moving forward to the next part, because activating a profile that's already on the SIM is not that exciting, because that's more or less the same as having a multi-IMSI SIM card. So I thought, let's do something more interesting. Let's use one of the devices and actually download a new SIM profile onto the device. And for doing so, you need an activation code. And I don't know, this is more or less the same thing. That's like basically the code that you scan if you use your phone for this. I know this consumer SGP.32 version. That's basically the code that your phone scans from a QR code. So let's use the device, the Murata one, and I'm gonna add a profile from Soracom. So I received one of these activation codes from Onomondo itself, and I can simply paste it in here. So I'm downloading or initiating the download operation. And again, the next time that this device connects with the EIM, the cloud orchestrator, it sees that there's a pending operation to download a profile. And to quickly remind you, I try to draw out this process a little bit in this drawing of mine. So let's say there's the device, and this device that runs the IPA. And the IPA can either run on the SIM card or on the device itself, on the MCU. So that IPA is directly connected to the EIM. In my case, that's Keegan. And with an activation code, you basically instruct the device to download a profile from a specific SMDP Plus database. So in the instruction is actually the endpoint where the device can download its SIM profile. So that's what's currently happening. So we have, in a minute, we're going to see if something is already happening as I'm walking through this process. And then the default operations are enable, disable, download, and delete. So you can, from the cloud, you can enable or disable a profile. You can download a new profile, or you can delete it. And there's some additional smaller operations like requesting information on what profile is active or what profiles are basically installed on the device itself. Okay, I'm going to refresh the page and seeing the status of this whole process that I'm going through. And while I'm doing so, I'm going to ask a question to Loic. So if I'm downloading a profile, like how big is a profile actually? Like how much data am I downloading?
Yeah, so good one, Lawrence. This varies quite significantly, but I would say it's in the typical range of 30K, I would say, between 20 to 50, depending on on the different MNOs, etc. And some large MNO group might have specific activation applets, etc. And sometimes they go all the way up to 100K. But for IoT providers, this is typically not the case. And more MNOs actually paying attention to say for their LP1, for example, use case, they want to make that light, or for battery operated devices. It's affecting the device life cycle time if we do large download for just that. So they reduce the size of their profile to the strict minimum as much as possible.
Okay, clear. So 20-30 kilobytes. And in the meantime, you see that the profile has been activated from the board here. So now it's activated and connected to Zariot. And there's a new profile added to the Murata board, which is called On Demand. And I can even show this in the portals from the different operators that there are now 2 active SIMs connected to Zariot. And I have not enabled this profile on the Mondo yet. So that's actually the next step. So the first is downloading the SIM profile. And secondly, I'm enabling this profile to complete the whole process. And then follow-up question, if a profile is 20-30 kilobytes on average, how much space is there on a SIM card? How many profiles can I actually download?
So on our product, we have the most compact OS of the industry. We have an 800K Infineon chip that we use for the most part, and our OS is roughly 500, which gives us 300 plus left for profiles. And typically for IoT, we see 2 to 3 max profiles being needed, right? It's not like you're traveling with your iPhone in many countries and downloading travel eSIM left, right, center. It's for fleet use cases for very targeted countries. Yeah, so typically we have plenty of space to manage the 2 or 3 typical number.
So if you say there are like 300 KB of space usually left, then I don't know, you can run up to 10 profiles on your SIM.
Yeah, typical, yeah.
But yeah, the question is, why would you? At least don't worry about not having enough space on your SIM.
Yeah.
So that's a good thing to have. Okay, refreshing here and also shows that it works through between all the different connectivity platforms. Let's say I'm also enabling a Soracom profile just to show that it's actually working with all of the partners that we're collaborating with. Okay, so in the meantime, at least the Zariot profile is active. I initiated the operation to enable a new profile, and here's actually something that's in progress. So things are happening on the background. But at least this already gave you a bit of an initial idea on what this looks like and actually how simple it is. And the beauty is it's all initiated from the cloud, and it's one of the big differences from the consumer version versus the IoT version, because I don't know, you cannot connect, like if you run IoT devices at large scale, there's no way to manually update IoT devices. So it all has to be initiated at scale from the cloud onwards. And as you can see here, the device will go offline at some stage because it's connected to one connectivity provider first. Then it received the instruction to change the SIM profile. So that means it needs to make the switch, for which the radio has to basically be reset to connect to a new connectivity provider. So that's currently happening, it seems. So that means that this is at the last stage of actually that profile change. So we're going to give this one more second. And in the meantime, I can show you, or I can introduce you on how much energy is actually being consumed. And I did a quick test here, which I will show you. So I created a baseline to give you a bit of a reference point, how much energy is being consumed if you're sending a message from 1 kilobyte. So I used these visualizations with the Koitek tooling that I just showed you that's lying on my desk. And for reference, I just simply send a message using the Nordic NRF 9151. And this is basically the power profile of sending a message. And it's not only sending a message, it also enabling, turning on the radio, connecting it to a cell tower, to a connectivity provider. It's sending data and it receives some data in return, probably a 200 OK message. And this process took 8.5 seconds and about 227 of microwatts hour. So let's use that as the base configuration. Then when I conducted this process and I did the test to download a profile, it took roughly 1 minute. In this specific example, it took 1 minute and 0.7 seconds. And it consumed 849 microwatts hour for reference. So the whole download profile roughly took 1 minute. And then the enablement of that specific profile, at least in my test, took roughly 30 seconds and another 500 or so microwatt hours. Just to give you some references, and I think that the time consumed for this process to take place, that was surprisingly fast in my opinion. So basically in under 2 minutes, you can have the downloads, the profile downloaded and activated. And of course, a good note to add here is that it also depends on how frequently you set the configuration, on how frequently the IPA checks in with the EIM. And for now, it's very quickly, once every minute, but I guess in a real world scenario, that might happen once a day or even less, maybe once a week or once a month.
If I may on this, I think it's really here we enable a very fast polling for good demos and really good experience for developers. But in effect, here we believe a business trigger will drive these changes, whether it's on device or somewhere centrally, and we do support those type of scenarios.
Okay, in the meantime, I'm doing another refresh, and let's see if the new profiles have been downloaded and activated successfully. So while the page is refreshing, we can already dive into some of the questions here. Oh no, there it actually is. So questions come later. As I showed you here, the SD wireless device now changed its active profile to Soracom, and the Murata one changed its profile to Anomondo. And now I can dive into more details about all of the platforms, but at least if you refresh, and it directly shows that a new SIM is now active, which is probably this one ending 020. And here you can directly see that the device was turned online and is now actively using this connectivity profile. Same for Soracom. In principle, it's the same connectivity provider, but it has a completely different UI and also a different, overview of managing all your devices. So thus far the demo. If there are questions about specific parts that you want me to highlight, I'd be more happy to do so. But before doing so, I want to do a quick roundup on what we actually saw just yet, and kind of a sanity check on where we are at the moment. Because my surprising conclusion was that everything works quite seamlessly, independent on the devices I'm using. So all of the devices that I work with seamlessly connected, and with the Keegan platform, downloading, enabling profile, that all seems to work seamlessly. But yet, in the question I would like to ask you, Loic, like, is that it? Is this it? Are there more elements that we need to keep into consideration when I'm actually going to deploy this at large scale to a fleet of, let's say, thousands of devices?
Yeah, so I'd say over the last, since we have certified EAM since 25, even before the eSIM was actually certified as well. And we've done a lot of this kind of groundwork, right? Making sure the module experience is good, making sure we iron out the key interop stuff. Yeah. So this is past, I'd say. And what's needed now is more the set of MVNOs and MNOs to make really embrace the journey of making their profile digitally available. And we have, notably among the partners today, we have Onomondo, Soracom, and Zayat who've already done that. They have an SMDP Plus, which is not necessarily, by the way, a Keegan SMDP Plus. We've also worked with many MNOs who use their own SMDP Plus, especially the big groups like the US carriers, for example. We can download their profile just fine, right? So it's more now the time of the business desire from the connectivity provider to say, yeah, I embrace the SGP.32 journey, and I most of the time already have an SMTP Plus for retail business, for you and me to source their profile with an activation code, right? Like Apple has already made successful. But to enable that for fleet of IoT devices, right? And that might mean adjustments in their business process into how they engage with the customers, etc. Right? So I think you have already a few companies who are already embracing that and making that and say, yeah, you can contact me and tomorrow you can get, I don't know, 10K activation code from us. And you get that list, you pop it in the EIM interface, and that's it. You can deploy those profiles to those cards. So there is not a big gap there. I would say it's more this commercial bit to wrap up, and that's where we see a good, strong adoption from OEM to actually source either blank eSIM, SGP.32 eSIM, or an eSIM with the main profile that they'd like to use. And then for, exotic geographies or constrained geographies, they download as they need, either in their factory or in the field.
Yeah. So it's really about the operational implementation. So I saw a few questions here on cross-connecting IPAs with EIMs. So for this demo, I used both your IPA and EIM. But let's say I source either my IPA or my EIM from a different partner. How does that work?
Yeah, so we've done some scenarios like that. We've tested, for example, EIM from third-party companies already, from Simplex, also with some of the big threes, etc. Right? So we do this work as well. This is part of the interop exercise, or eSIM with EIM, or EIM with third-party eSIMs. It's typically we try to anticipate that from the demand from the customer before the customer have to do it themselves. So we tend to do that quite a bit. Yeah.
Okay, interesting. So I also saw some questions on going into more detail about the actual times something consumes to download or enable a profile. So I'm actually gonna share my screen again, and now I have the device running connected with the power profiler. So this is the NRF 9151 that I directly connected to my computer. And so here I can turn on the radio, and there you can see that like the initial process where it's turning on the radio. Just to give you some ideas on how much and how long this may take. And in the meantime, I'm gonna enable a process, an operation, so live we can actually see what's happening. While at the meantime, we can already address some of the questions here at hand.
So maybe a comment on that, Laurence, would be that, yeah, you use the platform which are typically what we would call LP1, right? The NRF 9151, it's a CAT-M B module, same as the Sequence Monarch 2. These are platforms which we would consider as low-speed IoT, right? So if you work with, say, a CAT1 bis plus a CAT1 plus platform, the download of the profile is extremely fast. The download itself is extremely fast. Here we take maybe a minute or two, depending on the process. A large part, I think, is attributable to the time to download the profile, and the energy consumption is actually the actual download and radio exchange to download the files. But I think the important bit is to say it's good to have an understanding of profile size and how it can impact potentially your actual use case in the field. But again, this would be very infrequent event in the life cycle of a device. We don't do that on a frequent basis, typically just based on small location change, etc. It's when you have something that permanently changes in the state of the device that you would trigger, potentially this profile downloads.
Yeah, thanks. Let's see what other questions are coming in, and I actually have one question myself as well, and maybe can share some information on, like, does it actually cost money, without going into details, but I guess someone pays, you have to pay for all of this, right?
Mm-hmm. So it's fairly simple. I'd say on the eSIM, it's a one-shot cost, right? Which basically is to cover for the hardware itself, the Infineon chip, the packaging of the chip, the certifications, etc., and all the software licensing costs, so Kigen OS, and any fees regarding licensing to enable the product. So that's a one-shot fee for MFF2 card, to give you a rough indication. We're in the dollar domain, okay, dollar-euro domain, okay, in volumes. And then for the EIM, we don't have, at least at Kigen, a transaction-based model. The reason, again, saying that we want to enable the functionality with a fair use policy, but SIMs basically are part of a bracket which are registered on the EIM, and that you can use the EIM functionality as much as you'd like. Now, the one thing that you have to keep in mind is that depending on the connectivity provider, you might have a fee to access the digital profile, but here you're already dependent on the commercial strategy of, say, the connectivity provider. Some of them might reflect a fee, some of them not, so that's something you need to query. Kigen doesn't provide or resell connectivity. I think that's an important point, and that allows us also to work with the entire ecosystem of connectivity supplier in a relatively agnostic fashion.
All right, thanks. So in the meantime, I'm quickly showing that what the power profile looks like when enabling a new profile. So at some point you see that the radio turned on, turn off, search for a new network, and then started turning on again. So that's basically the last step of the change of a profile. So that's definitely one element of the time. And somewhere in here, the profile was initiated. So just to change the reconnection only takes a few seconds. And in this case, it might have taken roughly 1 minute before the full profile enablement took place, which was a bit longer than initially than with my previous example, but it's still within the 1 minute for this full operation to be executed. More information and follow-up will be actually shared with you, more insights into the power profiling of all of these operations. So that's something that we'll be sharing with you later. Okay, so I think we may have time for maybe 2 more questions or so. So let's see what questions have not yet been answered in the chat.
So yeah, I did answer quite a few of them in the chat directly and tagging the people asking the questions. So, but if you do have some more, just let us know.
Yeah. So maybe one thing on the IPAs and IPAEs and IPADs. So how many module vendors are actually implementing or have already implemented the IPA within their module?
To be fair, it's a pretty rare occurrence. And I can understand it from, I would say, desire to, for example, fully own and control and verify the software that runs into, say, a system at the low level. So I know one major module vendor who has done IPA inside some of their module, not their whole portfolio. The comment I would make there is, to me, IPAD really makes sense on complex and rich devices, in which case you want the IPAD to run on the MCU, to drive a Wi-Fi chip, to drive a cellular module, to drive a Bluetooth chip, to drive a cable connection. This is what we see in gateways. For example, we have a big project in India where we have very complex scenario where an installer would show up at the install site with his mobile phone, does a site survey on his phone, and then will push the right profile on the spot to the gateway for installation for broadband access in an apartment building, for example. So you see this type of really complex scenarios where here you have quite a bit of consulting and software development, but for a cellular-only LP1 low-power device, IPA just does the job.
Okay, so I hear that it's mostly designed for these complex scenarios, and IPAEs works well with most IoT devices with cellular connections only.
Yeah.
Understood. Okay, so there are two more questions, and I think those are short ones that we can dive into. And then I have one final question to you, Loic. So what's the minimum or the maximum polling interval that the IPAs can be configured to?
So if minimal, we take it as the fastest, it can go down to 1 minute. Again, it's really done for a demo perspective, because keep in mind, you drive data costs to do this. You might have a special agreement with your connectivity player, say, oh, maybe this cost is not part of my regular consumption, but the general rule is whatever you do with IPA drives data cost. So very frequent polling drives your data cost.
Okay. Anything on the footprint of an IPA on a SIM? Is that noteworthy?
It's part of our OS by default anyway. It's activated or deactivated based on the configuration and the presence of IPAD, but that's already part of this 500K. It's a few dozens of K, I think, if I recall, right? But it's fairly small.
Yeah, understood. Okay, then my last question, because I know there are more questions coming in, and I'm sorry you cannot address all of them, but what if people want to learn more, or what if people want to get started? Where would they go?
Yeah, so the best place to go is kigen.com/contact. You have an easy page where you have a small drop-down where you can select the topic you want to engage us. You have a specific SGP.32 trial drop-down. It's the best way because you'll fill up your information. You can describe a little comment to say, it's very useful for us when you put a comment, say, this is what I want to do, this is my timing, this is my volume. This helps us to get you better served in terms of answers if it's more qualified, in effect, right? Rather than just your name. So be as descriptive as possible. This will help us a lot to address your request from the get-go in a better way, all right, from the first answer. Me, I'm present on all the social network, LinkedIn, Twitter, IoT Stars event when I can. We had really a blast at the last event. It was really cool. So I encourage you to go there and interact with Lawrence and his partner. We'll be at the Things conference, for example, which is kind of a similar kind of a vibe, mood event. Really liked it since they open to cellular.
Perfect. Okay, so I know we're running out of time, but maybe you can share, because I did see that there are more questions coming in about the Bootstrap profiles. So is this something you provide by default, or is this like an additional service?
Yeah, so For the trials, we typically provide a bootstrap for a good experience, but this is not a commercial service. That's really for trial for unitary tests, right? Ultimately, again, we don't resell connectivity. And now we can redirect you to several partners who are interested to deliver that for you. And keep in mind that most of the partners, for example, the one present on that call, typically can manufacture actually an eSIM SGP.32 with their profile preloaded, right? So that's a possibility. It can be also, I know in the case of Soracom, that they'll make available their own SGP.32 eSIM with their profile branded Soracom. We help with the technology there, and they made an announcement on this already. So if you are interested, some of your connectivity partner can also already make SGP.32 their baseline, I would say, in the next few weeks and months.
All right. Thanks so much for sharing that last bit. So to round off, big thanks to Loic, a big thanks to all of the partners who helped us create this demonstration. It was a lot of fun to do, and it was surprisingly easy to actually get everything up and running. So big shout out to all of the partners, as well as all of the partners that are connected and supporting the IoT Stars community. And as Loic already explained, we have a big IoT Stars get-together planned during Electronica. So for more information, head to our website. And we'll also do a follow-up email giving you the recording of this session, sharing more information, where to learn more, and also how to join our future events. So thanks so much for joining. Thanks, Loic. Any last words from your end to the audience?
Yeah, no, thanks a lot for everyone who attending, all the good questions. Like it was great to see a lot of interest. And Lawrence, yeah, you did pull up a great demo. I think really important bit showing that here API integration of various platforms is working well, and you can have a combined journey of CMP plus RSP relatively easily now, and that's really encouraging to see all our partners on connectivity side also making great APIs available for a smooth journey. So that was great to see.
Okay, thanks so much. So hopefully this removed some of the friction you might have felt to get started with SGP.32. So I invite all of you to give it a try. Thanks so much for listening, and see you again next time.
Cheers. Thank you, Lawrence. Bye.